This is the summary created from the video, Cloud Economics. Cloud computing offers services without necessitating new infrastructure investments, making it crucial for organizations to determine the economic viability of migrating partially or fully to the cloud. Users access pooled and standardized computing resources with statistical multiplexing benefits, enabling location independence and better matching of actual demand to reduce overcapacity from peak load assumptions. Exploring economic factors like utility pricing, on-demand resource provisioning, and scalable elastic resources with minimal cost and delay can lead to reduced overhead costs through economies of scale and volume purchasing, while also overcoming the challenge of technology obsolescence. The coefficient of variation, which measures the dispersion of data around the mean, is a useful metric for assessing the risk-return, the trade-off of investments, with lower values indicating smoother demand curve patterns and better opportunities for effective resource provisioning through multiplexing demands from multiple sources. While customers may have varying demand patterns, some active during the day and others at night, perfectly correlated demand can lead to high peak congestion, necessitating a distributed service architecture with protocols addressing coordination, consistency, availability, and partition tolerance, with latency being a critical factor strongly correlated with distance and network hops. The viability of cloud pricing depends on the ratio of peak to average demand, with cloud being cheaper than owning when this ratio exceeds the utility premium, although hybrid models are often popular for efficiency, and other costs like network, overhead, and reliability also impact the decision. While linear demand can be manageable with periodic provisioning, non-linear and exponential demand patterns can be challenging in the cloud, with provisioning time causing resources to lag behind demand and incurring exponential penalties, necessitating careful study of demand patterns to match resources and avoid such penalties. Cloud resource provisioning calculations involve factors like peak computing demand, provision delay, and penalties for missed service, with assumptions such as peak demand and resource provision as functions of time, unit cloud resource cost, and penalty types like pay for use or miss service delivery. In summary, cloud computing offers services without upfront infrastructure investments, and determining the economics of cloud versus in-house is crucial, with factors like pooled resources, location independence, economies of scale, statistical multiplexing, demand variation, latency, utility pricing, and penalties for unmatched resources driving the decision to adopt cloud computing and leverage its benefits. Please stay tuned for more summary videos.